So we've been looking at this unit circle. We've looked at different points on the grid. Let's say we have a terminal angle that goes through the point out here, 5, 3. We can actually use that to find this angle by just making that into a right triangle. But what we're going to look at first is we're going to look at, okay, if that goes through that point 5, 3, what sides of this triangle do I know? Well, 5 would be which side here, vertical or horizontal? That'd be the horizontal. That's down here, 5 units. 3 would be the vertical. From that information, can I find my third side? Yes, I can. The square root of 5 squared plus 3 squared. That gives us 5.831. So what that does is that allows us now to find all of our trig functions of this angle. I'm going to call that angle theta. What is the sine of theta? Yes, it's always opposite over hypotenuse, so 3.5.831. It's 0.514. That's sine. What is the cosine of theta? Adjacent over hypotenuse. Good. So 5 over 5.831. Or 0.857. How about tangent of theta? Opposite over adjacent. So that would be 3 over 5. 0.6 is the tangent of theta. Let's get fancy here. Secant of theta. Hypotenuse over adjacent. Very good. So that's going to be 5.831 over 5, or 1.166. Cosecant of theta. Hypotenuse over opposite. So 5.831 over 3, or 1.944 about. Cotangent of theta. Adjacent over opposite. 5 over 3, or 1.667. Not so bad? So time to exercise your calculators a little bit. What if I ask you to find the sine of 40 degrees? What's it going to be? .643. Very good. How about the cosine of 40 degrees? 0.766. Good. Tangent of 40 degrees. 0.839. Okay, how about Secant of 40 degrees. You guys remember how to do secant? What function do you use? Perfect. It's cosine 40, you close the parentheses, and then the x negative 1, which is what? 1.305. Perfect. How about cosecant of 40? Use sine 40, close the parentheses, x negative 1, which gives us 1.566. 1.556, okay? And then finally, the cotangent of 40. Okay, so use the tangent of 40, close the parentheses, x negative 1, 1.192. Works for me. Any questions on how we calculate those functions? What if I give you that the sine of angle A equals 0.313? How do I find A? Think of A as like x. We have to get rid of the sign. What's the opposite of sine? Just like our logs and our exponentials, it is the inverse sine. On your calculator, you know how to do an inverse sine? What is A here? If sine of A equals 0.313, how do I find A? I'm solving the equation. What's been done to A is the sine. To get rid of it, we do the inverse sine. So the inverse sine and sine cancels out. A is equal to the inverse sine of 0.313. On your calculator, you do that by, you got it, second sine, 0.313 is 18.24 degrees. Very good. No, that negative 1 is not a reciprocal there, it's an inverse. There are actually several different notations for that. It is sometimes written instead of sine negative 1, it's sometimes written as inverse sine like that. Also sometimes written as arc sine. Because what you're doing is you're going from the actual ratio back to that length of the arc. Arc sine usually says it wants the answer in radians rather than degrees. We're kind of pulling our focus off of the radians though. If you did 1 divided by sine, by the way, that's a cosecant. So what if I have cosine of B equals 1.324? What's your calculator do? Error. Why is it giving you an error? Sine and cosine are always between -1 and +1, aren't they? Cosine can never equal 1.324. What if I tell you the cosine of angle C equals 0.888? How do we find C? Inverse cosine, very good. So the inverse cosine and the cosine cancel out. C is equal to the inverse cosine, 0.888, which is 27.38, we'll call it, degrees. How about if I tell you that the tangent of angle D is 4.73? Is that possible? Yes, it is. Tangent can be any value except for 0. So I solve that by doing what? Inverse tangent. Tangent and inverse tangent cancel out, giving us D is the inverse tangent of 4.73, otherwise known as 78.06 degrees. Perfect. So, on to the fun part. What if I tell you that the secant of angle F, 2.85? Well, obviously, we're going to use an inverse secant, aren't we? Well, technically we are. F is equal to the inverse secant of 2.85. But our calculator does not have an inverse secant button, does it? Let's scroll back up here where we did secants. To find the secant, we used the cosine function, then we did the x negative 1, right? The inverse, we are reversing that process. We're going backwards, which means the x negative 1 has to happen first, then we do the inverse cosine. So what we're really doing here is we're taking the 2.85, doing an x negative 1, and then we are inversing that cosine. So what happens is on our calculator, you do the inverse cosine, you type in the 2.85, but instead of closing the parentheses before you do the x negative 1, now you do the x negative 1 inside the parentheses. You get 69.46. Now, it's not too hard to get this part right, getting that x negative 1 in the right spot, because if you don't, if you do inverse cosine 2.85, if you accidentally close the parentheses first, your calculator will be kind enough to tell you you screwed up. It's an error, because you can't do an inverse cosine of 2.85. What you're really doing the inverse cosine of is 2.85 reciprocal, or x negative 1, which is 0.308 or 0.3508 or 3509. So let's see if you can figure this one out. If the cosecant of angle G equals 1.92, how do you find G? Okay, I think you got that right idea. See if that comes out for you. That sounds right. Yes, it is the inverse sine, second sine, 1.92 with the x negative 1 inside the parentheses, and you are correct, 31.39. What if I tell you that the cotangent of angle H is 0.091? That sounds right. We are technically doing an inverse cotangent. Cancels out the cotangent. So H is equal to the inverse cotangent of 0.091. But of course, the calculator doesn't have that function, so it is the inverse tangent of 0.091 reciprocaled. And I'm sure you're right. And you are, 84.80 degrees. What do you guys think? Not so bad? Ready for a quiz on it? What a way to come back, huh, Jeremy? I won't give you a quiz quite yet. Don't worry. I want to look at some relationships here. So we have our triangle. We label our triangle angles A, B, and C. We usually try to get the right angle to be angle C. We label the sides of the triangle then by the angle that it's an opposite of. So side A is going to be this side over here, and we label it with a small a. Instead of a capital letters for the angles, small letters for the sides. So what's this side up here going to be? Little c. It's our hypotenuse, and that's why we're trying to get that right angle to be c, is we're used to the hypotenuse being little c. So of course this down here is little b. Now remember, it depends on what angle we are looking at, which side is which. There's one side here that is always the same label. Which one is that? Yeah, the hypotenuse. Side C is always the hypotenuse, no matter what angle we're looking at. But if I am looking at the sine of angle B, sine, of course, is opposite over hypotenuse. If I'm looking at angle B, which side is opposite? Little b is opposite. So that would be little b over c. However, if I'm looking at the sine of angle A, still opposite over hypotenuse, but if I'm looking at angle A, which side is opposite? Little a. So that would be A over C. So we're going to focus on, for right now, angle A. So little a is going to be opposite. Little b is going to be adjacent. So we've already said the sine of A, of angle A, is side A over side C. What's the cosine of A? B over C. Tangent of A. A over B. Secant of A? Remember, secant is the reciprocal of cosine, so you just flip over the cosine. Cosine is B over C. Secant will be C over B. Cosecant of angle A. C over A. Again, that's just flipping over the sign. Cotangent of A? B over A. Without looking at the triangle, could you tell me the sine of angle B? We'll forgive you. Sine is opposite over hypotenuse. What's the opposite side if I'm looking at angle B? Little b. So it's B over C. Notice the relationship there. Sine of B is equal to cosine of A. A and B are complements. The sine of one is equal to the cosine of the other. Why are A and B complements? Because if a triangle is 180 degrees and we already have a right angle here, those two, A and B, have to add up to 90 degrees. So then, what would the cosine of angle B have to equal? You got A over C. That's going to be the same as the sine of angle A. Tangent of angle B is equivalent to the cotangent of A. If we keep going with this, secant of b better be equivalent to the cosecant of a. C over a, which it is. Cosecant of b better be equivalent to the secant of a. And of course, the cotangent of b, put a different color here. Cotangent of b better be equivalent to the tangent of a. So we got those equivalencies. Those are the cofunctions, remember. The co means of the complement, so it's equal to the function of the complement of that angle. Cosine of b means it's equal to the sine of the complement, or the sine of a in this case. There's other relationships between these angles we want to see. We've already seen, of course, that secant is the reciprocal of cosine. Secant is c over b, where cosine was b over c. And that the cosecant is the reciprocal of the sine. Sine is a over c, cosecant is c over a. And of course, the same relationship with tangent and cotangent. One we have not yet seen, well, maybe not at least. If I take the sine of a and I divide by the cosine of a, remember the sine of a was a over c, right? What was the cosine of a? B over c. If I divide those, a over c divided by b over c, we make it a over c times the reciprocal of c over b, and you're absolutely correct. The c's cross cancel out. We've got a over b. Well, a over b was tangent of a. So what that means is the tangent of a is equivalent to taking the sine of a divided by the cosine of a. If I do it the other way around, cosine of a over the sine of a, it's b over c divided by a over c. Well, b over c divided by a over c becomes b over c times c over a. And once again, the c's cancel out. I got b over a, which is the cotangent of a. So you can see there are all sorts of relationships between these trig functions. So if I know a couple of the trig functions, let's say we know sine of angle P is 0.6 and cosine of angle P is 0.8. Can I find tangent of angle P? Yeah, what's tangent going to be? You got it, sine of P over cosine P, or 0.6 over 0.8, or 0.75. Can I find cotangent of P? Yeah, that'll be cosine over sine. 0.8 over 0.6, 1.333, right? 1/3. How about secant P? One over cosine, or 1 over 0.8, which is 1.25. How about cosecant of P? Well, it's 1 over sine, 1 over 0.6, 1.667. And it doesn't have to be sine and cosine. I might have, let's say that the sine I got to come up with one that's going to work for me. Let's say the sine of angle M is 0.866. And the tangent of angle M is 1.732. Can I find the cosine of M? Yes, we know that tangent of M is sine over cosine, right? In this formula, we know that the tangent is 1.732. We know that sine is 0.866. We're looking for the cosine of M. I'm just going to go ahead and make this a proportion. So it's 1 times 0.866 divided by 1.732, because the cosine is 0.5. And of course, once we have sine and cosine, we can find all the rest like we did up here. What do you think? We're going to spend more time on these identities and stuff here, finding the functions from other functions. Today, your homework is going to be mostly on identifying the functions from the parts of a triangle, like we did at the very beginning. Next then is going to be calculating those functions from your calculator, like we did towards the beginning of class today. This is going to be in your new packet, which is labeled the Old Smith packet. On page 689 of that packet, exercise 33-2. Page 691, exercise 33-3. Page 693, any guesses? Exercise -5A. Page 694, exercise 33-5B. Yeah, I'll let you off the hook for 33-4.